Okay. So what we're going to do is we're going to work on polar points today, and we're going to get into a first couple of equations. Tomorrow we're really going to focus on a whole lot more of the like equation deals. So when we're looking at points, we're going to be given to them like this. It looks like an ordered pair where we have like an x and a y, but it's not x and y. What we have is r, so the radius, and theta, our angle. So the r is our radius, and the second piece is our angle from standard position. Sorry, I'm gonna have to move it. So it's our angle from standard position. Standard position meaning this, our x-axis, this is angle 0. So I've got this set up, so our very first set of points here, these are all in degrees. So let's start by labeling these pieces with their degrees. So looking at this circle here, we have a whole lot of lines on it. We know these angles. We know all these angles. But first things first, let's take our axes. What angle is this one up here? 90. So this one's 90 degrees. What's this guy? 180. This guy?
270.
That's our 270. So what's this one?
30.
That one's going to be 30. What's this one? 45. And this one? 60. So from here, we could follow our patterns. We could go all the way around, remembering back to those unit circle values. Oh, snap, what? Relevance. So it helps us to kind of review those unit circle pieces. So I do encourage you to go around and give these all their degrees, just because we are going to need to remember our unit circle stuff. But let's see what it looks like specifically to graph these polar points. So as I'm working through this, I am going to go ahead and do a whole lot of different colors on here. You can just do this with labels. I got to remember to stop zooming in so that you guys can actually see what's happening. So if we look at A, which is 4, 90. So what this tells me, my radius is 4. On our circle here, this littlest guy inside here, this is our unit circle. It has a radius of 1. So this little guy in here, that's our unit circle. So if we have a radius of 4, it means we're going to be out on this circle way out here. 1, 2, 3, 4. And if it's at 90 degrees, our point is going to be right here. So this is where we have point A. So then let's look at another one. Similar kind of vibe. So we're going to look for 310, or 3, 210. So angle 210, we know this guy's 180. This next one here, this is where we get angle 210. From standard position, it's over here. So if we want radius 3, it's going to be 1, 2, 3, right here. So this is our point B. So this was our 210. We could label this here, this is our 225. Like, we can label all these pieces just so that we can see them. Because sometimes that makes things easier. Sometimes we're going to get radii, that are negative, and that's okay. We can do the same thing, just how with our positive angles that go this way and our negative angles that go this way. If I have our C, which I'm going to grab this color, which we're going to do as 120, -1. Our angle 120 is this guy right here. So this one's our 120. And if we were on 120, it would be somewhere on this little right here. We go radius of 1, radius of 2, radius of 3, radius of 4. So if I want a radius of -1, it comes back this way. It follows it through like a line. Just like I could have -3, -4. I can go either direction on it. So our 120 -1 is this guy down here. This one is point C. I have to keep changing the zoom. I feel a little bit. Okay, questions on C. C tends to be the one that throws us off first. Okay, so very similar vibe for point D. We're gonna look for -3 at 60 degrees. So 60 degrees, we know that one, that's this guy right here. So if I had radius 1, it would be here, radius 2, it would be here, radius 3, it would be here, 4, 5. This one says on 60 degrees, we need to go -3. So 0, 1, 2, 3. It's still on the line that's at 60 degrees. We just went -3 from our circle. So 1, 2, 3. This guy right here should be our point D. Let's see if we can figure out these last two. 3, excuse me. Let's take a look at those. See what we can figure out on those last 3. Try and do those. -330. So remember what it means for our negative angles. Radius of -2.5. With negative angles, if it helps, you can rewrite it with a coterminal. So sometimes on these ones, it's easier to think of it as our radius of -2.5. And if I want the positive angle that gets me to -330, that would be a positive 30 degrees. So if I want to go -330, that's going to get me all the way over to here. So our -2.5 on here is going to take us 1, 2.5. It's right next to point B. This guy right here is where we're going to have E on the purple. Just a couple more on this one, and then we'll look and see what's different when we look at the bottom one. So if we have -45, 5, if we wanted positive 45, that'd be this guy up here. -45 is way down here. So we're gonna have our radius of 1, 2, 3, 4, 5 right here. So our point, F, bless you, is right here. One last on our kind of degree portion. We've got -2, 180. So angle 180 is this guy over here. If we have a radius of -2, if I want +1, +2, +3, so on and so forth, we have -1, 2 over here. So our point G is going to be right here. Questions on these guys? What's up?
Wait, how's G?
Because if we were on +180, that would be somewhere over here, right? So our +1, +2, +3. But if I want negative, I need to follow that same ray kind of backwards. We go -1, backwards 1. -2. Because if I wanted to do everything that could be on 180, it would be everything that could go this way with our positive radiuses. Or I could go this way. So we're going to look at those eventually. But everything on that line could be at -180. Or positive 180. So our degrees are usually fairly okay for us to get because our radians, or our radius is the first number, and the angle is our degrees second number. Our second graph and our second set of points is very much the same kind of vibe, but it's instead of in degrees, it's in radians. We are, for the most part, going to be working in radians, but it's good for us to be able to see them in both. But for the most part, for the rest of this packet, we're going to be working with radians. There are times when we can work with degrees, but for the most part, it's radians. So again, it might be helpful if you go around and kind of label your points, just so that you have kind of your orientation where you want it. We always have our x-axis as our angle 0. On radians, kind of the first one that's easy to fill in is this guy. What's this guy going to be? Pi. Which helps us remember that this guy here is going to be our pi over 2. I'm just going to bring this in so we can label stuff. My pi over 2. And the down here on the bottom, we're going to have our 3 pi over 2. Ooh, that did not give me a fraction. There we go. That 2 is trash. Try again. That 2. There we go. Made it a legible 2. That 2 was getting real bad. So we can fill in all these other angles. We know them. This is, when our denominator's 2, we have our over 3, over 4, over 6. These are all pi's. And this one has those same denominators, 3, 4, and then 6. And these are all 1 less than, so 2 pi, 3 pi, 5 pi. This has the denominators that flip their direction, so we're going to have our 6, and then our 4, and then our 3. These are all 1 more than our denominators, so we're going to have 7 pi, 5 pi, and 4 pi. And then the last ones are kind of the hardest to remember. Are 3, 4, and 6, and it's twice the denominator minus 1, so 3 times 2 is 6, minus 1 gives us 5 pi, 8 minus 1 is 7 pi, and 12 minus 1 is 11 pi. So remembering all our radian values is going to be something that we're going to need to have for the next 3 weeks. We need these pieces. So by relabeling them, it helps us kind of remember, refresh. That's why I'm never mad that this is at the end over here. So then it's the exact same kind of vibe. We're going to take our pieces and we are going to graph them. So we've got our radius and our angle. So we know our angle is 5 pi over 6. So we're looking over here on this guy with a radius of 3. So 0 is at the center. Radius of 1, radius of 2, radius 3. So this, bless you, this is our point A, right there. So then let's do the same thing with B. Again, when we have the negative radius, it's the same kind of vibe. We have our angle at 2 pi over 3, so that's this guy right here. Radius of 1 would be here, radius of 2 would be here, 3, 4, 5. So if I need negatives, we're going to take this same line and continue it through -1, -2. So our point B will be right here. This guy is B. C, same kind of vibe. We know our angle is pi, so we're going to be right over here on this guy here. with a radius of 4, positive 1, positive 2, positive 3, positive 4. That's how many out we go. So if we're on a positive radius, it's going to be exactly the angle we think it is. If it is a negative radius, we have to go with the opposite side. So like a vertical, like a reflection. So let's finish these out. So let's look at point D. So 3 pi over 4, we normally be thinking this guy over here. But with our radius of negative 2, we're actually on our 7 pi over 4. So we're down over here. We'd have 1, 2 down here. So this is where we're going to find point D. So again, try and see if we can finish these out. We've got our 3, 11 pi over 6, negative 4 pi over 6, and negative 5, negative 3 over 2. So see if we can figure out where these are going to go. Our 11 pi over 6 is an angle we know. We should wind up with our E right about there. See if you can get F and G up here. G is probably one of the trickier ones because we have a negative angle and a negative radius. So I'm going to put both F and G up here. F is going to wind up down here with that negative 4 pi over 6. G, when we have this negative 3 pi over 2, so instead of going around this way to 3 pi over 2, we go around this way for our angle negative 3 pi over 2. That's this guy up here. And then our radius of negative 5, we have to go down 1, 2, 3, 4, 5. So it should be right down here. So I could write negative 5, negative 3 pi over 2 in a different way. I could say that this was positive 3 pi over 2. And a positive 5. They do the same thing. They get you to the same point. Questions on these points? As they said, I know. Because we're going to be using these a bunch over the next week. Because by the end of the week, y'all are going to make one of these things. I've got one over there too, somewhere. Up on the top railing. Okay, so let's take a look at the next page and kind of practice with our points a little bit. So we've got 2 points here, and we're asked to write these points in different ways. So if we look at point L, which is this guy out over here. So we're on the back side of this front page. Making sure it's made. Cool. So I just didn't reprint it this year. So I was just making sure everything lined up still. Cool, cool. So back to that front page. Look at point L. Let's see if we can find a couple of different ways we can write that point. So first things first, if we want to just go straight for it, what angle is this on? Say it again.
Angle or radian?
It doesn't matter to me if you're in degree or radian.
5 pi over 6.
Yeah, so this is our 5 pi over 6. So I could write that point as with our radius of 5 and 5 pi over 6. Totally valid. That is one way of writing it. That would take it this way and put it out here. I could do this with a negative angle. I could go this way round. I could say this is negative, and it would be negative 7 pi over 6, because it would just be like going the wrong way around. So I could write this as the same radius of 5 with negative 7 pi over 6. Means the same thing. I could do a very similar thing, just kind of the other direction, where instead of taking a negative angle, we want to take a negative radius. So if I take this angle, our minus pi over 6, or 11 pi over 6, with a negative 5, I could do it that way. With 11 pi over 6. Those are all 3 different ways that we could write this. Or if we wanted another way, we could just go degrees. With our radius of 5 and our degrees, we're at 150 degrees. So it doesn't matter whether we use degrees or radians.
Oh, wait, so that counts?
That's a different way. I totally wrote it another way. We're good. Just trying to make sure we can switch between them in our head. Yes, dear. Yeah, let me write your pass. Okay, so do the same thing with m. It doesn't have to be radians and degrees. Like, you can do whatever order we want to. See what we can come up with for m for different points. So looking at point M here, so looking at M, that's this guy over here. What's one way we can write M as an ordered pair?
3, 4 pi over 3.
3, 4 pi over 3 is 100% valid. So I could write that as 3 and 4 pi over 3. What's another way we could write that? Negative 3 and what? Say it louder.
420 degrees.
Ooh, 420. I have to think for a second. Yeah. Negative 3. Yes. Sorry, I had to math it for a second. That totally works. Because that puts us with a 360, giving us this piece right here. Puts us at 60 degrees with a negative 3. Absolutely valid. We could also do that negative 3 with that 60 degrees. Oh, I need to put the degrees on my 420. Or we could do a positive 3 with our positive angle, putting us down there at 240 degrees. Also valid. Those are all valid ways of doing that. So you don't have to do degrees, you don't have to do radians, whichever one we have on these, write them as any points. However works for you, there's a lot of options. What's up? So just looking at trying to find either positive angle, positive radius versus negative radius. Just trying to connect the fact that we can go different ways to get to different places over here. So I could, like on M, I can do 4 pi over 3, that's this guy, this angle with a radius of 3. Or I could go with negative 2 pi over 3. That would also get us here to this angle with a radius of 3. That would also work. There are a lot of different ways we can write this because we know a whole bunch of coterminal angles. All of the angles that you have up here will wind up being coterminal. So like anything that has a positive radius, my 4 pi over 3 and my 240, those are coterminal. 420 and 60 are coterminal. My 5 pi over 6 and my minus 7 pi over 6 and my 150, those are all coterminal. So anything that has that same radius is going to be coterminal. So the next thing we're going to look at is we're going to start looking at what these are going to look like when we start getting into equations. So we have here a couple of pieces where we're going to look at what it looks like if we were trying to graph when our radius is 2. So the first thing we're trying to figure out is where is our radius 2? Well, on this circle, I have a whole lot of places where my radius is 2. I could have at angle 0 a radius of 2. I could have at angle 90 a radius of 2. I could have at angle 30 a radius of 2. This one just doesn't have our 45 on here because finding online graphs is annoying. So all of these angles that are up here have a radius of 2. So what is this looking like if I was to try and connect up all the places?
Circle.
It's a circle where my radius is 2. So a circle centered at the origin is going to be just a constant. So our center is on the origin, and that is the jankiest circle I think I've ever drawn in my life. But whatever. It's so pretty. I'm so good at art, y'all. Oh my gosh. I'm so good at drawing. So then the other thing we're going to be shown in this first section here is looking at if we're asked to graph when theta is 2 pi over 3. So if we think about where 2 pi over 3 is, we know this guy's pi and this guy's 0. This was our pi over 2. This guy is our 2 pi over 3. So we're used to thinking about 2 pi over 3 being this piece here. And it could continue outward. I can go further. However, we also just saw when we were graphing these points, we can include negative radiuses. Radiuses. So it's not actually just right here. We also need to include those negative radiuses. So it's going to be the full line like this. This is also 2 pi over 3. They just have negative radiuses. Radiuses. I don't know. Plural weird. Latins are weird. Radiuses sounds wrong, but I think it is righter. But I don't know. Kind of like octopuses and octopi. Technically, I think octopuses is correct, but nobody says it because octopi's fun on the side. Okay, so we can have positive or negatives on both of these. So then I want you to give C a try. See if we can figure out where negative 7 pi over 6 is. Oh, theta equals negative 7 pi over 6. Where are we going to get that line? Think about it for a second. Because if we had just a positive 7 pi over 6, that would be our, here's our pi and then our 7 pi over 6, so this guy here. So if we had a positive 7 pi over 6, it would be this angle. But negative 7 pi over 6 means I'm going to go around this way, and it's going to be this guy. So this is kind of our starting point of what we typically think of as negative 7 pi over 6. But again, I can have those positive radiuses or the negative radiuses. So it's this whole line like this. And again, I'm so good at drawing lines. What's up? And then our last bit that we're going to do for today is we're going to look at these bottom ones and we're going to see if we can name some equations. So it's kind of working backwards from the ones we just did. So we want to see if we can figure out what these could be called. And there are several ways of naming these. We can name them in radians. We can name them in degrees. We can name them with radiuses. We can name them with positive angles. We can name them with negative angles, all kinds of things. So when we have lines, that means we're looking at pieces like this one where we have an angle. So it's going to be a theta equals. So A here is going to be a theta equals, but what angle is it going to be? What will our theta equal here? 60 is definitely a valid option. We could do our theta equals 60 degrees. Or we could do pi over 3. We could also do this angle down here. We could go around and hit that negative angle, or the down here. We could do our 240, or we could do our 4 pi over 3. That also will give us the same line. Our 240 degrees, or our 4 pi over 3. Those all give the same line. So there's lots of different ways of writing these lines. What about for B? What's that one going to look like?
R equals 4.
Yeah, it's our radius. R equals, and we just have to count outwards. So 0 is right at the origin. 1, 2, 3, 4. Our radius is 4 here. So look at these bottom two. Look at C and D. And see what we can come up with for those two. Look at those two. Because that's going to be where we stop for today. So what could we call C? Oh, you're looking at D.
R equals 2. Oh, R equals 2.
Yeah, R equals 2. And then, what were you thinking for D?
Theta equals 105.
It's not going to be 105.
120.
120. We have 120 degrees. We could have our 2 pi over 3. Yep, we could do our 300 degrees. We could do our 5 pi over 3. We could do negative. Yeah, say there's a lot of choices on here. So we have lots of pieces in there that we could do with this. So what we're going to do for the rest of this week is we're going to start working on these kinds of shapes, but they're all based off of points like these. So when we're filling in things like tables of graphs of things, it's all going to be points based off of these guys. It's going to be points like these. In fact, they're going to be more like these guys, because we're going to do them in radians. Okay, so the rest of this packet is what we're going to do for the rest of this week. So that is everything to do with the individual points. So when we're looking at homework for this section, we're going to, I'm going to give you guys worksheets because it's a lot of pictures and these graphs are really, really obnoxious to try to draw by hand. So I printed them out. So this is the second to last homework. Second to last. And just a worksheet. So it's just points on the front and the kind of line thingies that we just did on the back with our radiuses and our angles. Okay, and then tomorrow we'll start looking at the rest of this packet where we look at kind of the funky shapes. These are going to be things you use again in like calculus. Like what we're doing here, this project and these packets were designed by the calculus teachers to help you guys build a skill that is something that is commonly struggled with. So we're not doing this just to be mean. It's part of the things we need to cover. So I do also have your chapter tests from last week graded. They should be in. If you want to see them, I've got them and you guys are welcome to look at them. If not, I totally get it. But honestly, they were not bad. They were not bad. Okay, so, but that gives you that kind of last test grade to kind of see where we are, what our plan needs to be, all those things. Again, the QR codes with the grade calculator are up there hanging from the ceiling. You can go into Canvas and play the what if game, what happens with the project if, blah, blah, blah. And that'll give you, that QR code will give you both your IU grade and the PIKE grade because they are slightly different in weights. IU weights the final a little bit heavier. So they have, the final be 30% of your overall grade. whereas we have it as 20%. So it's not a huge difference. It doesn't usually make a humongous difference. It would usually be the difference between like a B or a B plus. It's not a massive difference usually. The most I've ever seen it swing is like a half a letter, going from like a B minus to a B plus, or a C to a B minus. Like I've seen those kind of shifts, but not anything like a full letter. At least that I've seen.